Good evening, students. I am Ravindranath. I have been teaching chemistry for NEET and JEE aspirants for 20 years, more than 20 years. And today we will start with organic chemistry. In this, just we will see how to attempt maximum number of questions in chemistry. So, first we will start with fundamentals in chemistry. Many people think that organic fundamentals are very easy, but even in that also there may be some tricky questions. You know that in organic compounds carbon shows three types of hybridization: sp3 hybridization, sp2 hybridization and sp hybridization. And if there are 4 sigma bonds around each carbon, then it is sp3 hybridization. 3 sigma bonds sp2 hybridization, 2 sigma bonds it is sp hybridization. If it is sp3 hybridization, the shape of molecule is tetrahedral. sp2 hybridization, trigonal planar, and sp hybridization, linear. And if you take the percentage of S and P character, that you know, here it is 75% of P character and 25% of S character, 66.6% of P character, 33.3% of S character, and here P and S character 50% each. Okay. Now, if you take some examples in this, already you know this is a bond line model, and if you write its elaborated structure, this is a double bonded carbon. First you write like this C, here it is single bond, double bond C, and to satisfy tetravalency around each carbon, you place remaining hydrogen atoms. So, around this 4 bonds. Similarly, here one hydrogen, hydrogen. Now, if you count number of sigma bonds around each carbon, this is sigma and here it is pi. So, around this carbon 3 sigma bonds. So, what is hybridization? sp2, and around this also 3 sigma bonds, sp2, 3 sigma bonds, sp2, 3 sigma bonds, sp2. Now, we will take another example. I think you know name of this compound. This is buta 1,3-diene, an alkadiene. So, in this all the carbon atoms have same hybridization, that is sp2 hybridization. Okay, we will take another example. CH2 CH C triple bond CH. If you take this carbon, you write in this elaborated way and find out a number of sigma bonds. So, here 3 sigma bonds means sp2 hybridization, sp2 hybridization. Around this carbon 2 sigma bonds sp hybridization, sp hybridization. Like this you have to find out hybridization. Apart from this, calculating ratio of hybrid and unhybridized orbitals is also important. So, if we take some examples related to this one. I will take C2H4. You know this as ethylene, or IUPAC name of this one is ethene. Then there is a double bond between 2 carbons. You write its structure, then find out number of sigma bonds around each carbon. So, how many sigma bonds? 3 sigma bonds. So, sp2 hybridization. You know that carbon forms 4 bonds in its excited state. That is in excited state electronic configuration of carbon is 2s, 2p, one electron here, So 4 bonds, 4 electrons. Now if it is sp2 hybridization, this s orbital and 2 p orbitals involved in hybridization. So what is this orbital? Unhybridized orbital, or it is also known as a pure atomic p orbital. Then if we take the number of sp2 hybrid orbitals, at each carbon 3 sp2 hybrid orbitals plus 1 unhybridized orbital. Similarly, s orbitals of hydrogen atoms do not involve in hybridization. So here the number of hybrid orbitals, if we take 3 unhybridized at each carbon 1 and 2 hydrogens 2. This is hybrid orbitals and this one unhybridized orbitals. So if we take a ratio of, similarly here also 3, 1, 2. Then what is the ratio of hybrid orbitals to unhybridized orbitals? So total number of hybrid orbitals here 6, unhybridized orbitals also 6. Then what is the ratio? Like this. Now we will take another example. Okay, we will take benzene. What is the molecular formula of benzene? C6H6. Then this is the structure of benzene. Write elaborated structure of benzene: hydrogen, hydrogen, like this. Then you see how many sigma bonds around each carbon. So around each carbon 3 sigma bonds, 1 pi bond. So if we take total number of sigma bonds, so or first we will see what is the ratio of hybrid and unhybridized orbitals. 6 carbon atoms undergoing sp2 hybridization. In sp2 hybridization, how many hybrid orbitals are formed? 3 hybrid orbitals are formed, and at each carbon there will be 1 unhybridized orbital. So 6 carbons, each carbon 1 unhybridized orbital, p orbital. Then 6 hydrogens, s orbitals are unhybridized. So what is the total number of unhybridized orbitals? Then what is the ratio of this hybrid orbitals and unhybridized orbitals? With that you can calculate. Then we will see some more examples which are important in entrance point of view. Okay. So what is this compound? This is aniline. The IUPAC name of aniline, I think you know. This is benzenamine. Now we will see what is the hybridization of atoms in this aniline. Surround nitrogen, 3 sigma bonds and 1 lone pair. Let remaining carbon atoms of benzene, hydrogen, pi bonds, like this. Generally one may think that around nitrogen there are 4 sigma pairs of electrons. 4 sigma pairs of electrons, 3 sigma bond pairs and 1 sigma lone pair. So, based on the concept of hybridization, if it is a 4 sigma pairs around an atom, the hybridization should be sp3 hybridization. But in case of aniline or any other compound in which the lone pair of nitrogen involves in what is that? Resonance, the hybridization will be different. So, due to resonance, if you write resonating structure of this aniline, here this pi bond will be shifted in this direction. So, double bond H like this. Okay. Now, we observe this nitrogen. Now, how many sigma bonds around nitrogen? 3 sigma bonds and 1 pi bond. So, if you write resonating structures of aniline, in many resonating, how many resonating structures are possible for aniline? 5 resonating structures are possible. In majority of the structures around nitrogen, there will be only 3 sigma bonds and 1 pi bond. Because of that, the hybridization of nitrogen in aniline is to be taken as sp2, but not sp3 hybridization. Similarly, you can guess what is the hybridization of oxygen in phenol. This is phenol, and you know that the lone pair of oxygen involves in resonance. Without resonance, if you observe this oxygen, around this there are 2 sigma bond pairs and 2 sigma lone pairs. So, total number of sigma pairs 4. Then one may think that hybridization is sp3, but this lone pair involves in resonance. Because of this resonance, then what is the hybridization of oxygen in phenol? So, again you see, in majority of the resonating structures of phenol, there will be sigma, sigma, this is pi and this is sigma lone pair. So, around oxygen there are 3 sigma pairs. That is why what is the hybridization of oxygen in phenol? sp2 hybridization. Similarly, we will take another important example. This is a heterocyclic compound. What is the name of this compound? Pyrrole. So, in pyrrole, what is the heteroatom present? Nitrogen. Okay. If you take this carbon, around these carbons, if you write elaborated structure, there will be 3 sigma bonds. So, what is the hybridization of these carbons? sp2 hybridization. This is also sp2 hybridization. Then what about this nitrogen? I think you know how many valence electrons are present in nitrogen. There are 5 valence electrons. In that, how many unpaired electrons? 3 unpaired electrons. Then these 3 unpaired electrons involve in bond formation. Then what is left? 1 lone pair is left. So, this is lone pair. I think you know the concept of resonance, delocalization. If there is a conjugation between lone pair and pi bond, the lone pair involves in delocalization or resonance. So, when this electron pair, lone pair involves in resonance, then here this is shifted in this direction. So, if we take a resonating structure of pyrrole, here double bond, here negative charge, here double bond. Now, this one. Then, what about hybridization of nitrogen in this one? This lone pair is not free. If this lone pair is free, then around nitrogen there are 4 sigma pairs, then hybridization is sp3 hybridization, but this lone pair is not free. Then how many sigma pairs? Only 3 sigma pairs. So, what is the hybridization of nitrogen in pyrrole? sp2 hybridization. Like this, you can also try other examples. Already you know these examples like furan, thiophene. You can find out what is the hybridization of heteroatom in these compounds. That is, what is the heteroatom in furan? Oxygen. What is the heteroatom in thiophene? Sulfur. You can find out hybridization in the same way. Now, we will take a small gap, small break. Okay.
V3 News లక్ష్యం సమాజ హితం.
శ్రీ మహంకాళి జ్యోతిష్యాలయం సికింద్రాబాద్. ముఖం చూసి జ్యోతిష్యం చెప్పబడును. మేము కోయరాజులం. తాతల నాటి నుండి శ్రీ సమ్మక్క సారక్క కొండదేవతల పూజలు చేస్తూ ఉంటాం. అనుభవజ్ఞులైన కోయరాజు జి ధర్మరాజు గారు గత 33 సంవత్సరాలుగా సికింద్రాబాద్ లోనే స్థిరంగా ఉంటున్నారు. సెల్ 9005297753. ప్రేమ, పెళ్లి, సంతానం లేని వారికి, భార్యాభర్తల సమస్యలు, కోర్టు సమస్యలు, చదువు, ఉద్యోగం, వ్యాపారం, మనశ్శాంతి, లక్ష్మీశాంతి, ఆరోగ్య శాంతి, చెడు ప్రయోగాల నివారణకు శాంతి చేయబడును. మరియు నరఘోష, నాగదోషం ఉన్న వారికి, ఇంకా ఎటువంటి గ్రహాలకైనా పూజలు చేసి యంత్రాలు ఇవ్వబడును. ఇంకా ప్రేమ వశీకరణ, ధన వశీకరణ, భార్యాభర్తల వశీకరణ, సంతాన వశీకరణ, వ్యాపార వశీకరణ, విద్యా వశీకరణ, ఆరోగ్య వశీకరణకు పూజలు చేయబడును. గ్రహపీడలు తొలగించబడును. ఏ సమస్యలకైనా అంజనం వేసి చూసి చెప్పడు. అన్ని రోగాలకు వనమూలికలతో వైద్యం చేయబడును. ఈ సృష్టిలో దైవశక్తి ఉన్నది ఎంత నిజమో, దుష్టశక్తులు ఉన్నవి కూడా అంతే నిజం. నమ్మకంతో రండి, ఆయురారోగ్యాలతో వర్ధిల్లండి. సర్వే జనా సుఖినో భవంతు. మా అడ్రస్ మోండా మార్కెట్ వెనుక, ఇందిరాగాంధీ బొమ్మ ప్రక్కన, సికింద్రాబాద్. సెల్ 9000529753. సంప్రదించు సమయం ఉదయం 9 గంటల నుండి సాయంత్రం 6 గంటల వరకు.
Welcome back, students. Now we will see different types of organic compounds based on nature. That is aromatic compounds, non-aromatic compounds, anti-aromatic compounds. This is another very important area where questions are asked. Now we will see what are these aromatic compounds. Already you know that these compounds should be planar and they have to follow Huckel's rule. What is Huckel's rule? Presence of 4n plus 2 pi electrons is called Huckel's rule. That is Huckel's rule, 4n plus 2 pi electrons. Then if we take anti-aromatic compounds, these are also planar compounds. Planar means there should be sp2 hybridization, and these compounds follow 4n pi electrons. Now non-aromatic compounds. If compounds are not obeying any of these, then these compounds are called non-aromatic compounds, right? Now first we will see aromatic compounds. So here n value is 0, 1, 2, 3. Here also same thing. So now we will take one example. Name of this compound is, this cation is, how many carbons in the ring? 3 carbons. So cycloprop, there is a double bond, enyl cation, positive charge. So cyclopropynyl cation. Then whether it is aromatic or anti-aromatic or non-aromatic, how to see? Now what I do? I take in this Huckel's equation n as 0, then how many pi electrons? 1 pi bond, pi electrons, and there is a conjugation between this pi electron pair and positive charge. That's why this will undergo delocalization. That is, this pi electron pair involves in resonance. Now what is the nature of this cyclopropynyl cation? This is aromatic. Then I will give one important question related to this one. I take a compound like this, this one. What is the name of this compound? Cyclopropynyl chloride. Now we will see where this compound gives a white precipitate with aqueous AgNO3 or not. On addition of AgNO3 aqueous, a white precipitate is formed due to formation of silver chloride. Means this chloride should be ionizable chloride. If it is ionizable chloride, chlorine has more electronegativity than carbon. Then when it comes out as anion, Cl minus. Then what is left here? Positive charge. So if it is positive charge, then what is formed here? Cyclopropynyl cation. Cyclopropynyl cation is aromatic compounds. Now if you see the stability of these compounds, aromatic compounds are more stable than that of non-aromatic than anti-aromatic. This is stability of compounds. Now here, this is sp3 hybridized carbon. If you take this carbon, this is sp3. Whereas when it comes to this one, sp2, this compound is a non-aromatic compound. Whereas this compound is aromatic. This ion is aromatic. Now tell me, a less stable compound is converted into more stable ion. Now you can predict where precipitation takes place or not. Yes, this comes out as Cl minus, then only it is becoming stable aromatic. So a white precipitate is formed. Like that. Then I will give other important examples. You know name of this compound? This is cyclopenta 1,3-diene. What is the nature of this compound? This is sp3 hybridized carbon, whereas these are sp2 hybridized carbon. So this is a non-aromatic compound. This is not a planar compound. If this is also sp2, then molecule or ion becomes planar. But this is sp3 hybridized, that's why this compound is a non-aromatic compound. Now let I treat this compound with sodium hydride, NaH. Now I want to know where hydrogen gas is liberated from this or not, or the hydrogen present at this sp3 hybridized carbon, where it shows acidic nature or not. Now we will see, suppose it is losing one hydrogen. Here how many hydrogens are there? 2 hydrogens. Let one hydrogen is coming out as H plus. A compound which gives out H plus is acid, acidic nature. So when this hydrogen is coming out as H plus, then what is the charge over this carbon? Negative charge. Let this Na plus here. Now what is the charge of hydride ion here, which is coming out? H plus. This H plus combines with this H minus. So what is liberated here? Hydrogen gas is liberated, right? Now based on this we can say cyclopenta-1,3-diene shows acidic nature. Why it is showing acidic nature? Now observe this. If I take this anion, so what is this anion? Cyclopenta-dienyl anion. Now this is electron pair. This electron pair is in conjugation with this pi bonds. When it is in conjugation with the pi bonds, it involves in resonance. So this comes out. So if you see resonating structures, okay. Next resonating structure. And next like this we can write resonating structures. Now this lone pair is involving, this electron pair of negative charge is involving in resonance. When this electron pair involves in resonance with the pi bonds, pi electron pairs, then this lone pair is also considered as this electron pair is also considered as a pi electron pair. Then how many pi electron pairs in this one? 6 pi electron system. 6 pi electron. Now in Huckel's rule, what is that Huckel's rule? 4n plus 2 pi electron system. I take n value as 1. Then how many pi electrons? 6 pi electrons. So this cyclopentadiene, by loss of 1H plus, it is converted into what compound? Aromatic compound. Now whether its stability is increasing or decreasing, it is converted from non-aromatic to aromatic, means stability is increasing. Stability is increasing means it is ready to lose H plus. It is ready to lose H plus means what is the nature of this hydrogen? This hydrogen is acidic hydrogen. Understood? That is. Now we will take another example. This cation is known as tropylium cation. It is one of the most stable carbocations, tropylium cation. Now we will say nature of this tropylium cation. here this carbon is sp2 and this pi electron pair involves in resonance with this one. When it involves in resonance with this, then there will be delocalization of positive charge through conjugated mechanism, which is known as resonance. Now see this one. In this, all the carbon atoms are planar, and how many pi electrons are present? 6 pi electrons. 6 pi electron system means aromatic or non-aromatic? Aromatic compound. So this tropylium cation is aromatic. Now based on this one, we will see one good question. You have to think. I am taking tropylium chloride. Now tell me, where it gives a white precipitate with aqueous silver nitrate or not? Which is more electronegative here among carbon and chlorine? Chlorine is more electronegative than when heterolysis, you know that heterolytic bond cleavage takes place, then this carbon gets positive charge, this chlorine gets a negative charge. When chloride ion is coming out, then what is formed here? A white precipitate of AgCl, and this compound is converted into which ion? Tropylium cation. Now tell me, where this tropylium chloride gives a white precipitate with a silver nitrate solution or not? It gives a white silver chloride precipitate. Now okay, we will take this compound. Total how many carbons? 7 carbons ring. So what is the name of this one? Cyclohepta 135 triene. Will it react with the sodium hydride or not? We will see. What is the hybridization of this carbon here? sp3 carbon. Suppose it is losing H plus to show acidic nature. If it is losing H plus, then it is converted into anion. Now check, this electron pair is in conjugation with this pi bond. So this is also considered as a pi electron pair. Then total how many pi electrons? 8 pi electrons. Now tell me, will it follow Huckel's rule? No. It follows which one? 4n pi electron system. If n equals to 2 here. So how many pi electrons? 8 pi electrons. If it is becoming 8 pi electrons, okay, this is non-aromatic, and this compound is anti-aromatic. Now whether it is going, the system is going from more stability to less stability or less stability to more stability. It is going that is stable system to less stable system. Now tell me, will it show acidic nature? It will not show acidic nature. So like this, these are some important questions generally asked in organic chemistry. Now I will take some more examples. This compound is cyclobuta 1,3-diene. If we take this one, how many pi electrons? 4 pi electrons. 4 pi electrons means it is what type of compound? Anti-aromatic compound. Now we will take this compound. What is this one? Cyclohexa 1, 3. 1, 2, 3, 4. 1, 4 diene. What is the nature of this carbon? sp3. This is sp3. Actually here there are 4 pi electrons, but this is not planar. Then what is this compound? Non-aromatic compound. Like, now we will take another example. This is, I think you can name this one, cycloocta tetraene. How many pi electrons are present in this one? 4 pi bonds. One bond equals to 2 electrons. Total number of pi electrons, 8 pi electrons. Then one may think that it has pi electrons according to 4 and pi, and all the carbons are sp2 hybridized. So it is a planar compound. Then it should be, what is that? Anti-aromatic. But it does not exist in this shape. Because of a strain, it is changed into tub shape. Because of this tub shape, it loses its planarity. So this is a non-planar. Though it has electrons according to 4 and pi, it is not in a planar shape. It is in non-planar tub shape. That's why though it has 8 pi electrons, this is non-planar. I think you might have understood how to see nature of compound. This is one important area where questions are asked. Then tomorrow we will see some more questions based on this. I hope that you are understanding well. Okay, we will take break.